Today we're going to be talking about segment addition postulate. It sounds like a very fancy term, but it's actually a very simple concept. So what it is that part, so for example, this red part plus part, this yellow part, equals the total. Part plus part equals total. So you can think of it as like 3 plus 2 equals 5. Or you can think about like 3 inches plus 2 inches equal 5 inches. All right, because it's segment addition postulate, that same concept is going to be carried over into line segments. So this part of the line segment, AB, plus this part of the line segment, BC, is equal to the total length of the line segment, AC. Or if you would prefer exactly what I said, part plus part equals total. All right, let's look at a couple of examples. Let E be between D and F. Draw a diagram, then solve for X and the lengths of DE and EF. Okay, so if E is in between, then D and F have got to be those endpoints. So I'm going to do a little sketch. I'm going to put D on one end, F on the other end, and E has got to be somewhere in the middle. And I don't have any information about where E is, so I'm going to venture a guess that E is right there. And I can draw a more accurate picture when I know more information about those lengths. Okay, now it's given me some expressions for those lengths. The length of DE is 2x plus 1, and the length of EF is 3x minus 7. And then the length of FD, oh, that's the whole thing. That's the total from D to F or from F to D is 24. Okay, so I know a part, and I know the total. So I could actually set up the whole equation. Let's talk about that. So I know that this first part, 2x plus 1, plus this other part, 3x minus 7, are equal to 24. All right, now we're going to do a little bit of algebra. Let me move this up so you can see it better. We're going to combine like terms. So 2x and 3x make 5x. A positive 1 and a negative 7 give me a negative 6, and that's equal to 24. I'm going to add 6 to both sides to begin to isolate that variable. That cancels. 5x equals 30. We're going to divide by 5 on both sides, and we get that x equals 6. All right, that's one of our answers. We're solving for x. Now we also want to solve for DE. So to solve for DE, we would plug that back in and put the 6 where the x is. So 2 times 6 plus 1, or 12 plus 1, is 13. And for the length of EF, it's 3, and then you'd put the 6 where the x is. So 3 times 6 is 18, minus 7. So EF equals 11. So what I now know is that this part would be 13, and this part would be 11. And what I want to do is I want to check, do 13 plus 11 make 24? Yeah, they do. Look at that. If I added those two up, my total would be 24. Look at just problem number 2. All right, problem number 2 says to solve for x, then find kn. So I'm going to take this part plus this part and set those equal to the total right here. So let's write that out. X minus 2 plus 3x plus 4 is equal to 10x minus 19. You want to combine like terms. So I've got a positive x and a positive 3x. That gives me a 4x. I've got a negative 2 and a positive 4. which combines to make a positive 2. And then I have 10x minus 19. Now we want to get all the x's on one side, so I'm going to go ahead and subtract 4x on both sides. Now that cancels. I'm left with 2 equals 6x minus 19. I'm going to add 19 to both sides. It'll cancel over here, and I'm left with 21 equals 6x. Now to get x alone, we're going to divide by 6 on both sides. Okay, well, these cancel, and I'm left with 3.5 equals, oh, that looks like the letter Z, but equals x. All right, so they're solving for x. Now they want us to solve for kn. So all the way to n. So what I would do is I would put 3.5 where the x is. So I'm going to draw a little line here so you can see what problem I'm working. For kn, I've got 10 times x, which we know is 3.5, minus 19, or 35 minus 19, or 16, equals kn. Okay, that's it for today. Go try the practice.